Okay, so hello everyone. Today we're gonna learn about the correlation and linear regression. In this time, it is the Mochi case. So, the introduction, we will learn about the relationship between the two variables, which is the variable of x and variable of y. There is the numerical measures to express this relationship, whether it's weak or strong. Nah, the measure is called the correlation analysis. But firstly, it will report the relationship using the scatter diagram, as we will see in the next slide. The correlation coefficient. This coefficient describes the strength of the relationship between the two variables. It is symbolized with R, or it's referred to Pearson product moment correlation coefficient. Here is the shape of the correlation in the left image. It is whether has negative slope, it will go to the left side, and if it is the positive, it will go to the right side. And the characteristic is this coefficient range from -1 up to +1. And if the coefficient value is 0, it means there is no relationship between the variables of x and y. However, if it's near 1, for example, 0.900, it means there is a very strong relationship or very strong positive relationship. But if it's near -1, it indicates the negative relationship. Next, if the correlation is weak, we must also remember there is the large scatter in the regression line. But if the correlation has a strong relationship, then there is a very little scatter in the line. And here's the formula for calculate the correlation coefficient, that is R equal to the sum of x minus mean of x times with y subtract with the mean of y divided with n-1 times standard deviation of x times standard deviation of y. Here's the study case. Our store decided to use social media such as Instagram and TikTok to promote our mochi in hope to increase our total revenue. Every week we conduct advertise as you see in the data in the left side. In X variable, it is advertised, and then the total sales in every week are in the right side in Y variable. We want to analyze whether there is a relationship between the number of advertising we did every week and the total sales every week. As we can see in the table below, it is our advertised and the total sales. I also already calculate the mean of each variable in the bold type. So from this table below, here is the scatter diagram that show us the relationship between x and y. Even though I'm not calculate the coefficient yet, but we can assume from this line that we have a strong relationship because there is a very little scatter in this line. Next, before we calculate the correlation coefficient, we need to get this descriptive statistic table for each of the variable using the Microsoft Excel, because there are several values such as mean, standard deviation that We will use it later in doing the analysis of the regression. Next. Now, here is the time we're gonna calculate the coefficient. So first time in the third column, I'm sorry, there's a typo. It should be x minus mean of x, and also the y minus mean of y. So here is the x minus of x. It should be 10 minus 26.36. The value is minus 16.36. And next is the y minus mean of y. For example, in the first row, 20 minus 50.90, it will be minus 30.9, and so on until the last value. And then we're gonna calculate one by one. And then the value of x minus mean of x times y minus mean of y is 2.9036.363. And then we're gonna divide it with the n minus 1. Remember, our total n is 11. So it will be 11 subtract with 9. It is the 10 times with the standard deviation of x and standard deviation of y. That the data is already provided in the descriptive statistic table in the previous slide. So after calculated and divided it, we get the R value, or the correlation coefficient value, is 0.9247. And it is the strong positive correlation coefficient between x and y variables. Next, we're gonna test the significance of the correlation coefficient. We will test whether the correlation in the population is 0 or not. If the correlation is not 0, then it indicates there is a correlation with the number of the total advertised and the total number of total sales. So we're gonna test the null hypothesis is equal to rho, is the symbol that similar to P, but we must read it by rho equal to 0, and the alternate hypothesis is rho is not equal to 0. Then the formula is P equals to R square root of n minus 2 divided with square root of 1 subtract with the square of R, with the n minus 2 degrees of freedom. Here is, I use the 0.05 significance level with the degrees of freedom 11 minus 2, that is the 9. And then our critical value will be range from 2.262 and minus 2.262. And then we're gonna calculate the T. It is the 0.9247.3 divided with no, it is the 0.9247 times 0.3 divided with the square root of 1 minus the square of R, which is 0.8550, and then it will be, the value of T will be 2,335, and it means that we will need to reject the null hypothesis, because with our value is in the rejected area, it is larger from the critical value, which is the plus 2.262. It means that our correlation coefficient is not 0. Next, here is how we find the critical value. So in the previous slide, we used the two-tailed test with 0.05 significance level and 9 degrees of freedom. So we have the 2.262 critical of value that align with the 9 degrees of freedom here, and then the 0.05 in the above. Next is the regression analysis. If the coefficient correlation is different from 0, then we will develop equation to express the linear relationship between the variables of x and y. This equation will allow us to estimate the value of y based on the selected value of x that we input on the equation. The technique is the techniques to develop the equation and provide estimates with known as regression analysis, and the equation, it is called the regression equation. The best method to analyze the regression is using the least squares principle. It is the mathematical procedure that uses the data to position a line with the objective of minimizing the sum of the squares of the vertical distance between the actual y values and the predicted values of y. So firstly, this is the b of the slope formula, and then the a in the right side, it is the intercept, and in the middle, it is the form of the regression equation that we will calculate next slide. Here is the regression equation. Firstly, we calculate the slope or symbol with b. Here again, we use the data, which is the standard deviation of y divided with the standard deviation of x. So we're gonna times the r, or the 0.9247 times with the 22.154 divided with 15.33, and then the value of our slope will be 1.4292. And then next, after we get the value of the slope, we're gonna calculate the y-intercept. There is a equals to the mean of y, or the y bar, minus b times the mean of x. Then calculated it, we subtract and times, and then the value of our intercept will be 1.304. And then we input the a and b value into the equation of y. It will be 1.343 plus 1.4292 times with the inputted x. That we must input the value of x if we want to test the regression. And then next, here is the value of estimated cells after I input all the value of x into the regression equation here. And then after we get all the estimated cells, we're gonna input it to the regression line. And for the example, the equation is 1.3044 plus 1.492 times with the selected value of x. In this part is the 30, which is the example. It is equal to 45 times with 92. Here again, it is the plot in which the estimated value is 45 times with the 92. It is aligned with the 30 and then aligned with the y variable, which is the 45. It is plotted with the black circle. Okay, so next, here's the data provided by Analysis Toolpack. It is provided all the regression data from my study case. In the first table, it is the regression statistic. So we're gonna remember that the highlighted blue, it is the R square. It is equal to the coefficient of determination, in which I will tell you guys how to calculate it later. And then there is the standard error. And in the middle table, it is the analysis of variance table. From this ANOVA table, we know that our sum of squares, here is the SS in the third column. Our sum of square value, which is the 614.24, and it is the sum of square error value. And then the sum of square total, it is the 4,990 times with the 90 and so on. And then in the third table, it is in the highlighted blue, it is the standard error in the second column, highlighted with blue. It is the standard error of the slope estimated. It is the value that we need to remember because we will use it in calculate the formula. Now we're gonna test the significance of the slope. This step, we will analyze the regression equation by conducting a test of hypothesis to see if the slope of regression line is different from 0. Because if we cannot show the slope of the line is different from 0, we might use the mean of the dependent variable as a predictor rather than use the regression equation. So the formula is T equal to B subtract with 0 divided with the standard of error of the slope estimated. It is the value that we got from the third table. Here it is, the 0.193. So our null hypothesis, it is the beta less than equal to 0. And our alternative hypothesis is beta larger than 0. So we're gonna using the 0.05 significance level with the degrees of freedom 9. And we got our critical value is plus 1.833 because it is the one-tail test. So after using the formula and divided it, our T value is 7.3761, which means that it is in the rejected area. That means we need to reject the null hypothesis, and our beta or the slope of regression line is different from 0. And then we're gonna next to the standard error of estimate. It is the measure of the dispersion or scatter of the observed value around the line of regression for a given value of x. This standard error of estimate will describe how precise the prediction of y is based on x, or how inaccurate the estimate might be. Actually, it is also provided by the analysis toolpack table. But here I'm going to show you how to calculate it using its formula. It is the standard deviation of y times x equal to the square root of sum of square error divided with 9. So our value of the standard error of estimate is 8.782, which is the same as the value provided in the analysis tool pack in the previous slide. So here is the coefficient of determination, the proportion of the total variation in the dependent variable of y that is explained by the variation in the independent variable of x. This is very easy to compute because only square the correlation coefficient and convert the percentage to make it easier to interpret. So here is the square of r. Again, it is also provided in the analysis tool pack, equal to sum of square equal to 1 minus sum of square error divided with sum of square total. So our square of r is equal to 0.8581. So because I oftenly mention the analysis tool pack, here is the how to use the analysis tool pack in Excel. So first we're gonna click the data in the Excel and then click the get add-ins, and then you guys can search the analysis tool pack, and then you can add to your Excel. And after the analysis tool pack be added, you can click on the data analysis and click on the regression. And after that, you can input your X and Y range. And also not forget the confidence level. You guys can choose, but from the previous study case, I used the 95% confidence level. And then also the descriptive statistics. In the data analysis, you can choose the descriptive statistic to get the descriptive table of the X and Y variable. That is all for me. Thank you guys for listening.